Okay, so the last bit that we need to talk about is, so if this is where a 30, 60, 90 triangle fits, and the x component is square root of 3 over 2, and the y component is 1/2, what do I have this stuff over here about? Sine, cosine, tangent. Well, these are three functions that we dealt with a fair amount in integrated 2. I think you dealt with them in integrated 3 as well. That's the full spelling of it. Sine has an E on the end, but we never write the E. We just put down S-I-N, and in mathematics, we know that means sine, not sin. And then usually instead of the word angle, we'll put a Greek letter, and you've been seeing them use theta, right? So they'll say sine of theta, cosine of theta, and the tangent of theta. Now, some of you may have learned oh geez, that's terrible. SOHCAHTOA. Now I got it right over there as well, but I'm just going to write it up here too. And I want you to add this to your notes. This is a way to remember that the sine is the opposite leg over the hypotenuse. So I'm going to write down O over H. I'm going to say it again. You write it down. Opposite over hypotenuse. That's what the O and the H stands for, and that's why they're in that order. You've got to have the opposite up in the numerator and the hypotenuse in the denominator. It's a ratio. The sine is the ratio of the opposite leg to the hypotenuse. Well, we'll just look over here. The sine of 30 degrees across from the 30-degree angle, that's the opposite leg. The hypotenuse is 1. So this right here, the y value, is the sine. Let me draw a little arrow a little bit longer, and I want you to put y equals the sine of that angle. The cosine is the x value. So draw an arrow to the x, and why is it? Why is the x the cosine? Well, it's the adjacent leg over the hypotenuse. That's what the A and the H stand for. So the adjacent leg over the hypotenuse, and the tangent is the opposite leg over the adjacent leg, so it's the y over the x. So this one right here is the y value over the x value. Now, let me put over here also, the opposite over the adjacent leg. That's why it goes TOA, right? Now, I don't know if you learned last year that there are these things called co-functions or the reciprocal function. So we definitely have, SOHCAHTOA being very, very important. I definitely want you to have that down. But each one of these functions has what's called the reciprocal function, the co-function. So the sine, it has cosecant, and it's, spelled like this, cosecant of an angle. So you'd have cosecant of theta, but it's abbreviated CSC. So I want you to add that to your notes. It's abbreviated CSC. That stands for cosecant. And the cosine has a cofunction called secant. It's spelled like this, and it is abbreviated like this, secant, SEC. And tangent has a cofunction called cotangent, and it is abbreviated COT. So you go COT. Remember that funny 0 with a slash through it means theta. We often use the Greek letter, or a Greek letter, it doesn't have to be theta, to represent an angle. So what does that mean that they're the reciprocal functions? Well, if I took the reciprocal of opposite over hypotenuse, I'd have hypotenuse over opposite. If I took the reciprocal of adjacent over hypotenuse, I'd have hypotenuse over adjacent. If I took the reciprocal of opposite over adjacent, I'd have adjacent over opposite. You might say, well, what do we need 3 more functions for? We already have, these, they work just fine. It's just a way of simplifying expressions in the future when we're doing some more complicated trigonometry. And we're just trying to introduce you to those 3 functions right now: cosecant, secant, cotangent. Thanks for watching my videos, everybody. I hope that's helpful.